Day 37, number 8. We have a 10 milliliter sample of vinegar, which is acetic acid, aqueous acetic acid. It's titrated, so it's reacted with this concentration of sodium hydroxide and 16.58 milliliters of this sodium hydroxide, this solution, is required to reach the equivalence point. All right, that's where the moles of NaOH and the moles of the vinegar, or the acetic acid in this case, are the same. All right, so let's get out the highlighter here. What is the molarity of the acetic acid? And it gives you the density. What is the mass percent of acetic acid? All right, so we have a 10 milliliter sample, and that's my molarity of and volume of sodium hydroxide. So the first thing we need to do is probably write out the balanced chemical equation. Acetic acid, HC2H3O2 plus NaOH, producing NaC2H3O2 and water. All right, acid, base, salt, water. All right, is it balanced? Yes, it's balanced. So we have 10.00 milliliters. I want to know the molarity. We have 16.58 milliliters and 0.5062 molar. All right, we know it's not a limiting reactant problem because I do not have moles of, there's no way to get moles of vinegar. I'm looking for that, right? That's what I'm looking for. So I start with what we know. And we happen to know that we have 16.58 milliliters of NaOH. And we happen to know that for every 1,000 milliliters of a sodium hydroxide solution, there is 0.5062 moles of sodium hydroxide. And then mole ratio, it's 1 mole of NaOH, 1 mole of HC2H3O2. That's going to give us our moles of acetic acid, which in this case looks like it's 0.008393. Okay, so I'm looking for the molarity. And all molarity is moles per liter. Right now I have 0.008393 moles of HC2H3O2. And I have a volume of 10.00 milliliters. Well, I have moles per milliliter. I want moles per liter. So 1,000 milliliters is 1 liter. And I do that, I get 0.8393 molar HC2H3O2. And there is part A. Part B has the density going on here. And this density, remember, this density is 1.006 grams of solution per 1 milliliter of solution. Right? So that's the density. Well, how do you want to attack this? That's the question, right? How do we attack this? So if you start with the molarity, I have Mass percent is what I'm looking for. So I'm looking for grams of HC2H3O2 over grams of solution. I have molarity, 0.8393 moles of HC2H3O2 per 1 liter. And I have a density of 1.006 grams of solution per 1 milliliter of solution. So I can start with the density or I can start with the molarity. I think I'm going to start with the molarity. I mean, we're just going to do the same thing with them, but I'm going to start with the molarity. 0.8393 moles of HC2H3O2 per 1 liter of solution. I can take those moles into grams pretty quickly. All right, the molar mass of acetic acid. All right, 1 mole HC2H3O2 happens to be 60.06 grams of HC2H3O2. Right, because 16 is 32, plus 12 and 12 is 24. That's 56, plus 4 more is 60, and then there's 06 with the carbon and the hydrogens. Now we got grams of acetic acid, which we want. Now I need to have grams of solution, right? And so we know 1 liter of solution is 1,000 milliliters of solution, and 1 milliliter of solution is 1.006 grams of solution with the density. And there we go. And then we'll have our answer if we multiply that out. And we get 5.00% HC2H3O2 by mass.